Welcome to this video. Here we are going to be talking about variable length subnet masks, VLSM. What that means is our subnets can change depending on what we need. It's no longer tied to a /16 or a /8 or a /24. It means each network can be separated. It is important when we are talking about subnets, we are talking language. If we are saying usable or hosts versus actual. So I may say something like, I need a network that has 32 usable hosts. Or I need a network that has a total of 64 hosts. They're different. If we are talking usable normally will denote that we have a ID and broadcast. Those aren't usable addresses. Usable means within our range. So if we are talking hosts, when we start doing our subnets, we need to remember we need to add 2 because we're going to be losing one for our network ID and we're going to be losing one for our broadcast. Usable is just what's in the middle. For example, let's say I have a network, or I'm designing a network that has this criteria. I have 2,000 hosts, 200 hosts, 1,280 hosts, 64 hosts, and I have 3 interconnection devices, each having 2 hosts. So I need to be able to figure out a network diagram based off this information. There's a few rules that we need to follow. Rule number 1, sort them greatest to least. Rank them greatest to least. 2, remember if we're dealing with hosts, we need to add 2. That just is not working out well. And we should be able to take it from there. So let's go and work through a problem. So I opened up OneNote and I'm just going to fill out the information. So I'm going to do 2,000. I'm sorting these greatest to least. 264. And I have 2 networks that have 2 hosts each. Because the word host was used, I'm going to make sure to add 2 to all of these. So that means I'm actually going to be subnetting based off of I don't like that it is auto-correcting some of this. 66, 202, 12,082. I just want to make this look a little prettier. So 202 is the next one. 66, 4, 4, and 4. So I'm going to be building out a chart. And so what I've done is I've ranked them greatest to least. I've added the 2. And now, because I'm working on trying to figure out the different subnets that are needed, I have to figure out the groupings. And the groupings are based in binary. So we were pretty familiar with this chart from our binary conversions. And the nice thing is, when we're dealing with our hosts, the groups don't reset. It just keeps doubling. So here, this is actually 65,000 times 2, and so forth. but realistically I'm not going to be displaying multiple millions of host counts because we're really going to be working in the third and fourth octets. And I'll supply you with this chart. So we know that we need a subnet that gives us at least 2,000 hosts. So using the chart, we're going to put a 1 above the 2,000. To the left, all of these bits are going to be 1. Everything to the right will be zeros. In a previous lecture, when we were talking about host bits and network bits, the 1s are the network bits, the zeros are the host bits. Since we are looking at groupings, we look at where the first one is on the right-hand side, and we are doing groups of 8. So our group that will give us 2,002 hosts will be groupings of 8. And next we need to figure out what our subnet numbers are going to be. And for that we go back to our chart and we add up where the 1s are. Again, since we're doing groups of 8, we add all these 1s up. That equals 255. Add all these 1s up, they equal 255. We add these 1s up, these should equal 248, and this will equal 0. So the subnet is 255.255.248.0. So let's fill that in our chart. This will be 255.255.248.0. The important part here is realize that we are working in the third octets. That becomes important when we start figuring out our subnet. Now we go into the next network. We need a network that will give us 1,282 hosts. So I'm going to take this, I'm going to get rid of all of this. I need 1,282 hosts. 1,024 is too small. So sadly, we have to go to the one that can accommodate it, which will also be the 2,048. And again, everything to the left of that will be 1s, everything to the right is 0s. And again, convert it to decimal, 248.0. Again, our grouping is 8. That's where the 1 is. Groupings of 8, and our subnet is 255.255.248.0. Next network, we need to figure out that will fit 202. None of the fourth octet will work, so we have got to go over here. 1 there, and everything to the left again will be 1s. Everything to the right will be 0s. Let's convert it to decimal. Important to note where the grouping is. The grouping is in the 1 position. That's where the 1 on the far right hand side is. Again, I'm looking at this guy right here. So a grouping of 1, and the subnet is 255.255.255.0. Next, we're going to figure out where our network of 66 will go. 66 can't go in any of those. 66 is too big for that, so it has to go in the 128. And again, everything to the left is 1s. Everything to the right of that will be 0s. Do the math again. 255, 255, 255, 128. And again, the 1 is in the 128 slot now. So the grouping will be 128. I'm going to explain the groupings when I get to the actual filling out of the rest of the chart. 128, that's the subnet. And we just keep working down till we have the groupings of all the different networks. Next network is a network that will give us 4. 1 won't do it, 2 won't do it, 4 will. And again, everything to the left of that will be 1s. Convert it back to decimal. This should be 252. Again, recognize where the grouping is. Groupings will be groups of 4. Subnet is 255.255.255.252. Groupings of 4. Subnet is 255.255.255.252. And that's going to be the same for the remainder ones. So 4 and 4. Same subnet. So it's important to note that groupings just let us know the range of addresses we have. And the subnet focuses on which octets we are increasing by. So that gives us our starting point. The nice thing is, it doesn't matter what our starting IP is, so whatever the network design or network architect gives us, we can start with pretty much anything. I'm going to go ahead and expand out my chart. So I'm going to say the first one is going to be our network IDs. Next one is going to be our start range. So start and end, and our last one will be our broadcasts. For this example, our network engineer said start with the IP address 10.0.0.0. The address itself really doesn't matter. As long as we start with zeros, it's fine. So what we do from here is we figure out which octet we're working in, pretty much where there is a number not 255, and we're going to add 8. So we are adding 8 to the third octets. Here's our network. We are adding 8 in the third octet. So 10.0.0.0, adding 8 in the third octet. 0 plus 8 is 8. So that is the first start of the first network. The second network, we are also adding 8 in the third octet. It builds off each other, so keep that in mind. So here, since we started with this network, now we're working with this network. We are adding 8 in the third octet. 10.0.8 plus 8 is 16.0. So second network done. Next, we will work with the third network. We are adding 1 The fourth network is all zeros. So we are actually adding 1 still in the third octets. Here we were working the third octet because it's not 0 and it's not 255. Here, realistically, we don't want to work in octets that have zeros, so we're working in the third octet still. 10, we are adding 1 to 16, so 16 plus 1 in the third octet is 17.0. We did that because 16, we're adding our grouping, plus 1 is 17. So we have our first 3 networks done. These guys are all, that's the start of all of them. So we're going to go on to the fourth network. Notice here we can now work in the fourth octets. All of these octets are full So we need to work in the 4th octets. So that's what we're going to do. We are going to add 128 to the 4th octets. So we look at this network and we add 128 to the 4th octets. 10.0.17.128. 4th octet's 0. So 0 plus 128 is 128. So the first 4 networks are now done. Now we go on to the 5th network, which is a grouping of 4, and we're adding that to the 4th octet still. 128 plus 4 is 132. Not 132. So that network is done, so we go on to the next network. 132 plus 4 is 136. So now we have the last network we're adding. 4, grouping of 4. We're adding it to the 4th octet. 17.140. So a lot of people go, well, how did we, there's no network here. How did we get that? Remember, since we started with the network of 10.0.0.0, all of these shifted down 1. That's why this one does not have a network attached to it. So now that we have our network IDs, those are our starting points. I normally say let's start with the beginning and the end, and we can figure out the middle when we're done. So we're going to do our broadcasts. How we do our broadcasts is binary subtraction. I've already done a video explaining binary subtraction. So what we're going to do is we're going to look at the next ID, and we're going to subtract 1 from the far right bits. We can't subtract 1 from 0, so we're going to subtract 1 from the 3rd octets. And we get 10.0.7.255. Again, I have a video explaining how to do the math on that already. And we just work down our chart. This one, the second broadcast, we look at the 3rd ID and we subtract 1. For the 3rd broadcast, we look at the 4th ID and we subtract 1. Again, we're subtracting 1 from the far right, but because we cannot subtract 1 from 0, we're having to work in the 3rd octets. Here, we are going to be doing the broadcast for the 4th network. We look at the 5th network and subtract 1. We can subtract 1 from 128. So it will be 17 still, and we subtract 1 from the 128s. For this one, we look at the next ID, and we subtract 1. 17.131. For this one, same thing. We look at the next ID and subtract 1. 10.17.135. We have 1 left to go. 10.0.17.139. Again, we look at the 140, subtract 1. And that's all we need for our broadcasts. In fact, I'm going to change the chart a little bit because I want more room in our starting points. I'm going to start with our starting points. We are adding 1 bit in the 4th octets. Addresses cannot be duplicated. We only can have 1 address used. So 10.0.0.0 is already used. So we go to the next available address, 10.0.0.1. For the second network, we start with 10.0.8.1. Again, 10.0.8.0 is already used, and so forth. 16.1, 10.0.17.1, 10.0.17.129. Oh, so, but wait. How is this network starting with 17.1 and this network starting with 17.129? Again, look at the broadcast. Broadcast is the end. So this network actually ends at 127. So 129 is actually not in that network. 17.133, 10.17.137. Again, this is just used for growth, so this is any additional larger address above that is outside the scope of what we need. Next, we go to the end. The end will be one less than our broadcasts. 10.0.7.254. 10.0.15.254. 10.0.16.254. 10.0.17.126. 10.0.17.130. 10.0.17.134. 10.0.17.138. And there is our subnet in a nutshell. We have 7 networks. Here is the starting IPs. Here's the network IDs of those 7 networks. Here's the starting usable. Here's the ending usable in those network ranges. These ones, you'll notice, only have 2 usable addresses, 10.17, 10.0.17.137 through 10.0.17.138. That's only 2 addresses. Remember from the beginning, we only needed 2 usable addresses, so they work. So here's how we take our addressing. And the goal here is then be able to apply this to a network scheme. That is for a later video as we wrap it all together. This is basic subnetting. Remember that an IP will have an IP and a subnet. The subnet really just dictates the grouping of addresses. That's the entire purpose of the subnet, is dealing with the groupings of addresses. If you have any questions or concerns about this material, please let me know. Thank you.